This is Lesson 1, 3.7, Implicit Differentiation. This is a new concept. We're going to start off with an introduction. So consider the expression 2f of x minus 5f cubed x. You might say f of x to the power of 3 plus x to the power of 7 minus 1. What I'm going to ask you to do here is to take the derivative of this expression. So let's see, we would have 2 times the derivative of f, which would be, f prime of x. Then we come over here and we have 5 stuffed to the power of 3. So I'm going to bring down the 3, multiply it to the 5. So we have 15 stuff to the power of 2 times the derivative of the stuff plus 7x to the power of 6. So we've done this before, and that should have been pretty straightforward. Let's take a look at the second one. In this case, I'm going to have 5x to the power of 2 minus x cubed times f of x plus f of x to the power of 4. And again, we're going to find the derivative of this. This is sort of a warm-up. You should be able to do this at this point. Press pause and then check your answer. So here we go. We have 10x minus. Now we have a product here. One way to do this is to keep the negative out front and then do the derivative of the product. So we would have x cubed times f prime of x, first term times the derivative of the second, plus second term times the derivative of the first. See, and then we had to put that in parentheses because the minus applies to both parts. Then we have plus, and we employ the chain rule again, 4 stuff to the power of 3 times the derivative of stuff. That's one way to do the problem. I want to show you another way, the way that I like to do it. We would say here again 10x for the first term, and then I would treat the minus x cubed as if it's plus a negative x cubed. So that would lead me to first term would be negative x cubed times the derivative of the second, f prime of x, plus second term, f of x, times the derivative of the first, and that would be a negative 3x squared. Then I continue on, 4 stuff cubed times the derivative of the stuff. And you see it's the same. The only difference is I didn't have to distribute in the second way because it was already done for me. That was example 2. Let's move on here. Number 3 is that expression here. We're going to find the derivative. Please avoid the quotient rule. So the last term we would write f of x to the power of negative 1. So the derivative of 5 is 0. Again, we have the product rule. So negative x times f prime of x, first term times the derivative of the second, plus second term, f of x times the derivative of the first, which is negative 1. And then over here, again, this is f of x to the negative 1 power. So I'm going to bring down the negative 1, and that's going to combine with this negative to make it plus f of x to the power of negative 2 times the derivative of the stuff, f prime of x. Okay, let's take a look at the next one. In this one, it's going to be a little bit different. Let me write the expression here. 5x to the power of 7 f of x to the power of 4 minus f of x equals 2. So this is different because it's an equation. So the goal in this here is to find f prime of x. We're actually going to solve for f prime of x. But before we do that, I want to come over here in the margin. Suppose that I had x minus 1 to the power of 2 over 3 plus 4 equals 10. Now, if you were solving this back in algebra, you would subtract both sides by 4, but I wouldn't show that. I would say x minus 1 squared over 3 equals 6. I would just do it. So I had this row, and then I'd have the next row. And then after that, I would multiply both sides. I wouldn't show anything. I would just do it. I'd multiply both sides by 3. In the next step, I would take the square root of both sides, and that would give me plus minus the square root 18. And then the last step, I'd add 1, so 1 plus minus square root 18. So the reason I show you that is we're pretty comfortable. You should be comfortable with doing that. Some people do this and try to think, well, this is wrong. They write equals, 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 equals. And that is technically wrong if you're reading it. That would imply that this here is equal to the 10, which it's not, and so on and so forth. It would imply that this here equals 18, which it is not. So we don't write equals, equals, equals every time. We just go line by line by line doing the operations. So that's going to be true over here when we try to find f prime of x. So first thing I'm going to do is take the derivative of both sides of the equation. So I'm going to write it out and then show prime that I'm going to do the derivative of both sides. Let's do it. So we do have a product here. So first term times the derivative of the second. 4 stuff to the power of 3 times the derivative of the stuff, plus second term times the derivative of the first, 35x to the power of 6, minus, and then we have f prime of x, and then that equals the derivative of 2, which is 0. Again, the ultimate goal is to solve for f prime of x. So what I want to do is I want to look at the terms with an f prime in it, and I want to factor out an f prime from those terms. So when I factor it out, that's going to leave me with 20 x to the power of 7 f cubed x. That factored out of that term. Now when I factor out of this term, it's a minus 1. See, but now I still have this here, and this does not have f prime of x in it. So I want to bring that to the other side via, in this case, subtraction. So minus 35 x to the power of 6 f to the fourth x. Like that. And then in my final step, f prime of x equals negative 35 x to the power of 6 f fourth x all over this entire quantity, 20x to the 7th f cubed x minus 1. Just like that. So example number 5 is another equation, and you're also going to solve for f prime of x. So I'm going to do the derivative of both sides, and I'm going to write that derivative. I suggest you press pause now. Really do. Press pause, work it out, and then check your work. Here is the first line. The product rule here will yield this answer, and the product rule here will yield this answer. And of course that will equal f prime of x, yielding this line here. So what have I done? I put all the terms that have f prime of x together on one side, so I'm circling the f prime terms. Now this one here had to be brought over to the side. That's why I have a negative f prime of x. Now it would also work if I brought them all over to the right hand side. What I did in this particular case was I took the terms that do not have f prime of x, the ones circled here in purple, and I brought them to the other side. So it's going to be minus this term and then plus this term. That's what leads me to my equation at the bottom here. So the next step is to factor out an f prime of x, and I'm left with x squared minus 3x cubed f squared x minus 1. And that, of course, is going to equal the right-hand side. The last step is to divide that quantity, like that. A couple important things. It is possible that you have these reversed, as long as the negative is in front of the 2x and the positive is in front of the 3x squared. These terms at the bottom can be rearranged as long as their terms have the right sign. You could have also had the opposite of this. Perhaps you had plus 2x f of x minus 3x squared times f cubed x. That's okay as long as all these terms at the bottom also were opposite as a sign, kind of like multiplying top and bottom by -1.